Hi everyone, so in this video we are going to be starting on logarithms. So before we actually talk about logarithms, we're going to go over a few things about exponents again just to make sure everybody remembers and everybody's okay with it. So remember, an exponent just means multiply it by itself that many times. So like 2 cubed is 2 times 2 times 2, which is 8. 2 squared would be 2 times 2, so 4. 2 to the first just means 2. It's just itself. The trickier ones come with 0 and the negatives. So anything to the 0th power is 1. And the negatives just mean that you're going to flip the answer upside down. As in 2 to the first was 2, 2 to the negative 1 would be 1 over 2. 2 squared was 4, so 2 to the negative 2 would be 1 over 4. Then 2 cubed was 8, so 2 to the negative 3 would be 1 over 8. Right? So real quick, try to do the right-hand side. I will put up the answers in just a second, but same thing, just using 4 instead of 2. So like 4 cubed, 4 times 4 times 4. What is that answer? So I'll give you a few seconds, pause the video if you need to, and here are the answers. So take a look, make sure you got them all. Hopefully those are okay. And then we're going to start talking about them in another way. So we're just going to be asking a question now. So what exponent do you need to put on a 3 to get an answer of 9? So what I'm asking is this right here. What would that question mark have to be to get 9? Well, 3 times 3 is 9, so it'd be 3 squared. So the answer is 2. We'd have to put an exponent of 2 onto it to get 9. Okay, what exponent would you have to put on a 5 to get 125? Well, 125 is 5 times 5 times 5 again. So it'd be 5 cubed, so 3. All right, what exponent do you put on a 9 to get an answer of 1? Okay, again, anything to the power 0 equals 1. So if it equals 1, that means the power was 0. Then what exponent do you put on a 5 to get an answer of 1 over 25? Well, the answer is a fraction, so that means we know it was flipped, which means we know that our answer is going to be negative. And then to get 25, that's 5 times 5, so 5 squared. So negative 2 would be our answer. All right, for number 3, same exact idea. I just didn't write the question explicitly anymore. But we're still just thinking, what would the power need to be for those sides to match? So 10 to the x equals 100. Well, 100 is 10 times 10. So x would equals 2. 3 to the x equals 27. 27 is 3 times 3 times 3. So that's 3 cubed. So the answer would be 3. All right, what power do we put on 5 to get 5? Well, we didn't change anything. It's still just 5, so that'd be a power of 1, because a power of 1 doesn't change anything. All right, 60x equals 1. So remember, as soon as we see that equals 1, we should be thinking that that power is 0, because anything to the 0th power equals 1. All right, for e, 60x equals 1 over 6. Again, remember, as soon as you see the fraction, that means it was flipped. That means it's going to be negative. And since it's still 6, it would be negative 1. All right, 3dx equals 1 over 9. Again, fraction, so we know it's going to be negative. And 3 times 3 is 9, so it's 3 squared, so negative 2. All right, this next one's a bit harder. So 9 to the x equals 3. Well, 9 times 9 would be way bigger than 3. It's not, like 3 isn't a fraction, so it's not going to be negative. And it's definitely not 0, because that would equal 1. So instead, what do we know about a relationship between 9 and 3? Well, we know that the square root of 9 is 3. And remember, square root is really an exponent. You can write that as 9 to the 1/2 power equals 3. So that's going to be our answer. It's going to be 1/2, because that's square root. All right, and then we get to h. 2 to the x equals 5. So again, for this one, if we start trying to think it through, 2 times 2 is 4. Okay, that's a little too low. 2 times 2 times 2 would be 8. That's too high. So it's not 2 squared, it's not 2 to the third, it's somewhere in between. And honestly, we don't have the tools to deal with this one yet. That's not something that you can just easily pull out of your head. This one's going to be a kind of nasty number. It's not going to be just a fraction or anything like that. Right? So consider that last problem, 2 to the x equals 5. The question here is, what exponent do you put on a 2 to get an answer of 5? There's no integer that works, so how do we solve? For that, we are going to talk about a new function. It's going to be a function that's the opposite of the exponential function. And this new function is called the logarithmic function. And we define it as follows. So the function y equals log base b of x, and that's how you say that. This is log base b of x, is the logarithmic function with base b where the base has to be greater than 0 and not equal to 1. So same rules for the base as with exponential functions. Further, y equals log base b of x has the same exact meaning as that base to the y equals x. All right? So log base b of x is literally just going to be the answer to that question that we've been asking so far. All right? It tells you what exponent you have to put on that base to get an answer of x. Right? So just to show you what I mean, let's look at a couple of examples. So log base 2 of 8 equals 3. This is the exact same as saying 2 cubed equals 8. Those are the same exact thing. So one important thing to notice is that the base is the same. Whatever was inside the logarithm becomes the answer for the exponential. And the answer to the logarithm becomes the exponent in the exponential. Okay. Log base 3 of 9 equals 2 means 3 squared equals 9. Same exact thing. If we start with that base, the number on the other side is our exponent, and the number inside the log is the answer to that exponential equation. And lastly, log base 4 of 1/16 equals -2 means 4 to the -2 equals 1/16. Again, if we start at that base, go to the other side, that's going to be our exponent, come back around, and that's the answer. Okay, so before we start evaluating these and start playing with these a lot more, we're first just going to practice switching back and forth between exponential and logarithmic form. All right, so for example 4, we have log base 5 of 125 equals 3. So we're going to start with the base, and that's going to be the base for our exponential function. Or sorry, exponential equation rather. Then we go to the other side of the equals. Whatever's on the other side of the equals is going to be our exponent. So in this case, our exponent is going to be 3. Then we put it equals, and we come back around to see what is inside of the log. Whatever's inside of the log is going to be our answer. All right, let's look at another one. So log base 3 of x equals 2. So again, start with the base. So it's going to be 3 squared. Sorry, base is 3. It's going to be squared because that's what's on the other side. Then equals whatever's inside, so that's x. And in this case, we're not going to, because we're not actually trying to necessarily solve this. Like, we're going to leave it like this because that is the exponential form. But in this case, 3 squared is something we know, that's 9. We actually solved for x. Like, we already actually solved a logarithmic equation in this as well. Just keep that in mind for much later. We'll be talking about how to solve those equations. That's the idea. All right, number 6. So again, start with the base. Base is 10. Go to the other side of the equals. That's your exponent. Equals whatever is inside of the log. So 1 over 100 in this case. Last one. Start with the base. In this case, we have base e. Remember, e is just a number. So we're just going to have e like this. Go to the other side. So it'd be e to the first equals whatever's inside the log, which is x. All right, let's try going the other way now. So we're going to write each equation in logarithmic form now. So we have 3 to the 4th equals 81. Again, we're going to do the same exact thing about going around the equals. So we're going to start with the base still. This is going to be log base 3. Go to the other side. That's what's going to be inside of the log. So it's log base 3 of 81 equals 4. That's changing it to a log. So next one, it's going to be log base 9. 3 is going to be inside, equals 1/2. Next, we have log base 5 of 1/5 equals -1. Okay. And by the way, this is the first one that it really matters because it's a little hard to tell. anytime you can't quite differentiate between, okay, is this number down here in the log, or is that part of the base? Anytime you can't tell something like that, you can just put whatever's in the log in parentheses, and it does make it a lot more clear. Later on, we're going to have a lot more stuff inside of the log, so you're going to see that pretty often with the parentheses indicating what's inside of it. But just know it still means the exact same thing. And then we're going to do our last one. So our last one is the same as the question that we couldn't answer. So 2 to the x equals 5. So let's rewrite it. It's going to be log base 2 of 5 equals x. And we've actually solved for x. Your calculator can actually do this one no problem. All right? So if you do put this in your calculator, you would get x is approximately 2.32. That would be our answer. Again, this one's an approximation, but that's what exponent you would have to put on 2 to get 5. All right, so with that said, with rewriting it out of the way, let's talk about evaluating. So evaluating a log just means that we're going to be asking that question that we were asking at the beginning of this video. So it's always going to be, what power do we need to put on the base to get whatever is inside? Right? So like for number 12, this is really asking 10 to what power equals 100? Well, 10 times 10 is 100, so that power would be 2. So the answer is 2, and it's just 2. We don't need the log anymore. It's not going to be log of 2 or anything like that. The answer is just 2 because we just want the exponent. All right, so number 13. This is asking 2 to what power equals 1/4. So remember, we see a fraction. That gives us a hint that it's going to be a negative because we flipped it. And then 2 squared is 4. So -2 would be our answer. All right, number 14. 4 to what power is 64? Well, it's 4 times 4 times 4. So that's 4 cubed. So the 3 is what we want. All right, I'm going to leave 15, 16, and 17 for you to practice. Again, same exact idea, just ask that question that we were asking at the beginning. And if 17 looks a little more difficult than the other ones, I highly encourage you to go back and look at one of the examples we did earlier with a 9 and a 3. All right, so I'm going to give you a few seconds. Pause it if you need more time. But the answers are going to pop up now. So the answers are 1, 0, and 1/2. Right? So hopefully this gives you a basic understanding about what a log is. Again, a couple things you need to remember. A log is the opposite of an exponential function. Right? You can rewrite one as the other. So you can always change a logarithmic equation into an exponential equation. And a log itself is just an exponent. It's the answer to the base to what power equals what's inside. All right? It's just an introduction. We're going to do some more with it in the next couple of videos, but that is a good place to stop for this one. So I will see you in the next part of logarithms. Thank you.